Hi folks, today we're going to talk about solving systems using elimination. This is another topic from Algebra 1 that we carry on into Algebra 2. And so today we're going to review the steps, we're going to practice a little bit, see if we can get you to remember what you did in Algebra 1. So, the step 1 is to manipulate all of the equations so that the like terms, like the x's and the y's, those all have to be aligned. And when I say aligned, I mean vertically, like they need to be lined up vertically. X on top of x, y on top of y, equal sign on top of equal sign, constant on top of constant. They all need to be aligned vertically. Step 2, ask yourself, are the coefficients, remember a coefficient is a number that's out to the side of a variable. So if I have the term 3x, 3 is the coefficient. So ask yourself, are the coefficients of one of the variables opposites of each other? If the answer is yes, proceed to step 3. By opposites of each other, I mean, is one of them a positive 3x and one of them a negative 3x? So are the coefficients positive 3 and negative 3? Positive 9 and negative 9? Are they opposites of each other? So if the answer is yes, proceed to step 3. If the answer is no, then you have to make those coefficients be opposites of each other. You have to multiply one equation or both equations by numbers that will ensure that you have one set of opposite terms. Remember, opposite terms mean that they have the same variable, same number, but opposite signs. Once you have that taken care of, you move on to step 3. You want to combine the equations together, meaning you want to add down. If you did this right, then one or both of the terms will be eliminated. That's where elimination gets its name. Finally, once you do that, you'll be left with one variable in an equation. You need to solve that equation for the remaining variable. And then the last two steps are the same as they were in substitution. Once you get one value, substitute it into one of the original equations and write your answer as an ordered pair. Remember that we all link this back to our graphing systems notes, where we graphed two lines and the solution was the place where the two lines intersected. And so we are still looking for an ordered pair x comma y. Obviously, if your two equations don't have x's and y's, maybe they have r's and t's, or they have w's and v's or something like that, then you wouldn't write them as an ordered pair because that just doesn't make sense. You would say w equals blank and v equals blank. But if you do have x's and y's, you want to make sure you include them as an ordered pair because that's your solution. So I'm going to try to keep, there we go. I'm going to try to keep the steps all on the screen and look at example 1. Example 1, step 1. We want to manipulate the equations so that the like terms are all aligned. Remember, x on top of x, y on top of y, equal on top of equal, and constant on top of constant. Step 1, that's done. I'm going to go ahead and change colors here for my checking. Step 2. Are the coefficients of one of the variables opposites of each other? Well, the coefficient of this x term is 2. The coefficient of this x term is 1, so those are not opposites of each other. The coefficient of this y term is positive 1. The coefficient of this y term is negative 1. Those are the same number opposite signs. Those are opposites of each other. So I'm going to move on to step 3. I'm going to go ahead and combine my equations by adding down. So I'm going to draw a big line underneath and a big old plus sign outside. I'm going to add down. So I see that 2x plus 1x gives me 3x's. I see that 1y plus negative 1y is 0. Those are eliminated. I have my equal sign, and I have 13 plus negative 4, and that gives me 9. So my coefficients were aligned. I'm sorry, I should have checked these earlier. My coefficients were aligned, and I had 1 and -1 as my y coefficients. I combined, so I added down, and now I need to solve that remaining equation for x. So to undo this multiplication, I would divide, and I get an x value of 3. So finally, I'm going to do what I did yesterday. I'm going to take my remaining value. I'm going to substitute it back into an original equation. It doesn't matter which one you use. I tend to like the first one a little bit better. So the first equation was 2 times x, which is now 3, plus y equals 13. Well, I have to do this product in order to finish, so 2 times 3 is 6. And to get rid of this constant, I want to subtract 6. So 6 minus 6 is 0. Y equals 13 minus 6, which is 7. So my solution is an x value of 3 and a y value of 7. Now, you don't really know if this is your answer unless you check it. So I want you to pause the video and check your answer. So when you substitute 3 for x and 7 for y in each equation, you do end up with correct statements. So the solution is true. It is 3, 7. So I'm going to scroll down to number 2. Number 2 does have a fraction, which we've learned. I mean, we've had a fraction in every set of notes when we've talked about systems, and we've learned that they're really not all that hard to deal with, especially when they're 1/2. So that's not so bad. So step 1 is to manipulate the equation so that the variables are aligned. X on top of x, y on top of y, equals on top of equals, and constant on top of constant. That is already taken care of in number 2. In step 2, it says, are the coefficients of one of the variables opposites of each other? Well, my coefficients are, let's see if I can, there we go. My coefficients are 1/2 and -2. Those aren't opposites of each other. And these coefficients are 1 and -2. Those aren't opposites of each other either. So I'm going to go ahead and erase that. I can't move on. Nope. There we go. I can't move on until I have opposite terms. So if I don't have opposite terms, I'm going to multiply one or both equations by something that'll give me opposite terms. And I know that we always want to avoid, well, students usually want to avoid fractions, and that's okay. If I look at the y coefficients, 1 and -2, what would be the opposite of -2? +2. So what could I multiply 1 by to make it +2? I could multiply it by 2. But I can't just multiply one term by 2. I've got to multiply everything by 2 to keep it fair. So I'm going to distribute this 2 to each term in my equation. So 2 times half of x is 1x. 2 times 1y is 2y. And 2 times 4 is 8. Next step is to combine, to add down. So I have -2x's plus 1x, that's -1x. -2y plus 2y, that's 0, they get eliminated. And -6 plus 8 is 2. I don't want -1x, I just want x. So I'm going to divide both sides by -1. And I get x equals -2. So now I want to take that value, I want to substitute it into one of my equations. It doesn't matter which one. I actually kind of like this equation that we created when we multiplied by 2. So I'm going to go ahead and substitute it there. It's okay that it's not an original equation. It's kind of a variation of an original equation. So x, which is -2, plus 2y should equal 8. If I move the constant to the other side, I get 2y equals 10. And if I divide both sides by 2, I get y equals 5. So my solution is -2, 5. Again, we don't know that that's actually correct until we check it, so I want you to pause the video and substitute your answers back in to make sure that your solution is correct. Pause your video. So when you substitute -2 for x and 5 for y, in each equation you end up with true statements. So -2, 5 is your solution to the system of linear equations. So I'm going to move on to number 3. And I'm actually going to help you start it, but then I'm going to hope that you can finish it. So on number 3, look at it. Is everything aligned? Yes, we got lucky. Everything has been aligned in all 3 of our examples so far. X's, Y's, equal signs, and constants are all aligned. Now I want to see if I have opposite coefficients. The x coefficients are 5 and 8. Those aren't opposites. The y coefficients are 3 and 3. Those aren't opposites, but they're pretty close. In order for them to be opposites, one has to be a +3 and one has to be a -3. So that means I want to multiply an entire equation by what? In order to make a 3 a -3, I'm going to multiply an entire equation by -1. And make sure that I distribute it to all terms in that equation. So I'm going to ask that you pause your video, distribute your -1 so that you have opposite coefficients for y. And I'd like for you to continue the problem as far as you can. Even if you can go all the way to checking your solutions, I want you to pause your video and attempt the remainder of the problem. So at this point, I want you to check your work, check your checking, check your solution. And I want to make just a general announcement that if whenever I ask you to pause your video and try the problem on your own, you're not pausing your video, you're just copying down the work and the answer, you're doing yourself a great disservice. So for those of you who are pausing your video and you are trying to work it out and you are checking back, you are gaining more from these videos. So I really appreciate those of you who are following the instructions, pausing, and trying it on their own. Check your answer. And we're going to move down to example 4. Now example 4 is going to be similar in the sense that I'm going to get you started, and then I'm going to ask that you complete it on your own. In example 4, ask yourself if everything is aligned. Is everything aligned? Yes, everything is aligned. Ask yourself, do you have opposite coefficients for x or y? The answer is no, you don't. For x, 3 and 2 are not opposite coefficients. For y, 5 and -3 are not opposite coefficients. They have opposite signs, so they're closer, but they aren't the same number with opposite signs. So you need to multiply an equation, or both equations, by something to get those opposite coefficients. Now, I tend to look at the y coefficients because one is positive, one is negative, so they're already closer. But there's no nice, pretty whole number that I can multiply -3 by to get it to be -5, right? So what I'm going to have to do is multiply both equations. And if you can see that both 5 and 3 are factors of something, and you know what to multiply by, then that's great. If not, the trick is just to kind of switch the numbers around. So in the top equation, I'm going to take this +5, I'm going to multiply by 3. I'm not going to change the signs. The signs are already the way that I want them. I'm going to take this bottom equation, and in order to change this, I'm going to multiply it by the 5. So do you see how I just kind of changed them around? And that way the y coefficients are both going to be 15 and -15. They'll be the same thing, just with opposite signs. So I'm going to ask that you do that distribution for each of the equations, write your two new equations, and continue the elimination process. Pause your video and check back for the answer. So as you look at your answer, don't just check the solution. Check to make sure that your equations match up with my pink equations. Check to make sure that your work when you solve for x matches my blue work for solving for x. Check to make sure that your substitution of -4 for x looks like my substitution for -4 for x, or perhaps you used the other equation. Check to make sure your work looks the same. Then check the solution and make sure that you check your solution yourself, like I did in yellow. So this is solving systems by elimination. It was just a bit of a review from Algebra 1, maybe pushing it a little bit to get you to remember. I also want to remind you that the practice for this solving by elimination set of notes, the practice is attached to the substitution practice from last week. So make sure that you go back and you complete the elimination parts of the assignment, and that way you can submit the entire assignment when you're finished. Have a great day, y'all. Bye.